Welcome today to the series on sequences and series, and we're going to just start off the first one just by basically going through the introduction and the definitions of what sequences mean and looking at a variety of sequences and series and just getting an intro into it so we can start exercise 3. So let's define what a sequence is. Well, it's a set of numbers, letters, objects, anything really, as long as there's an order to it and there is a pattern or a rule. And so what we then need to say that each of those numbers or patterns or objects is called a term. And then what we do with these terms is if we add them all together, we get a series. And that's what a series is, and we use symbols to do it. And that's a summation. So we use a capital S with a lower n, or we use this sigma that you can see here. So let's look at it here. We've got the 4 is the final term, so that's where we get to 1, 2, 3, 4, and we start with the 1. It says at the bottom there 1, and the rule is 3n, and we can see the 3r. What does that mean? Well, we're going to start off with 1, and then we're going to do 3 times 1, then we're going to do 3 times 2, etc., etc. And so you should be able to see we get these 4. And a series, don't forget, is a summation of all of these. So I'm adding them all together, a sum of. So that's what that sigma is. Now there's a symbol we can use. We use the R, or we can use a different type of symbol, A and K. Sometimes they use N. There's a whole range of ones you can use. It really doesn't matter. You can just select what you want or just follow with what the question is doing, but remember to keep in line with what they're suggesting. The other thing we look at is deductive. How do we actually find the value from outside? So two types. One is deductive, one is inductive. Deductive is taking the formula like 5n plus 2. We want the fourth value, shove that in, 5 fours, 20 plus 2 is 22. So we know the fourth term is 22. That's deductive. Now, inductive is on the inside, a bit like Fibonacci sequence, recurrence formulae, stuff like that. So to find the next value here, you times the first value by 5, take away 3. So say it starts with 2, 5 2s are 10, take away 3 is 7. And so that's how you find those formula there. Now, two types of sequences, there are 3, but the two main ones we look at: arithmetic, basic level, a bit like your straight lines, y equals mx plus c. We have a starting value of a and a common difference of d. It's very similar to that, very straightforward, shouldn't pose a much of a problem. It's, as I said, straight line. That's an example here of 5, 7, 9, 11 and 15. And let's first of all put the terms above, 1, 2, 3, 4, 5, and let's squeeze between those the actual formula, the algebraic a plus the first difference, and a plus 2 lots of that difference, etc. Now, what we want to try and do is how do we write this out in a general term? So we need to think about that, and in order to do that, we need to find out what the value of d is. What is the difference? So we take one term and subtract the previous one. So 7 take away 5, 9 take away 7. It's really quite straightforward. And if you did that, you come out with a difference of 2. We know our a value is 5. We can see that's our first value there. So we write it as 5 plus 2d. That's the arithmetic sequence. Now let's consider the geometric sequence. It's a bit more interesting, and we have a starting value of a, very similar, but this time we have a common ratio of r. And so that's slightly different. And let's take an example, 0.5, 1, 2, 4 and 8. So let's put the terms 1 to 5 along, and let's squeeze between now the algebraic way of writing these. Now notice it's ar squared, ar cubed. So it's slightly different in that. And so for here we need to find the value of r. We can see the value of a is 0.5, but what would be the value of r? Now very similar to the previous one, you look at two of them. Here you look at one term and divide by the previous term. So if we did ar divided by a, we'd get 1 over 0.5. Now we know r equals 2, and we know the first value of a is 0.5, so we could write it in the general form of a r to the k. But what we've got here is going to be 0.5 bracket 2 to the power of k, and that's how you'd write the geometric. Now, we also have periodic sequences. Some of these are really odd. So for instance, let's take an example of the hours you studied maths during the COVID-19 virus. A general week starting on Sunday. Here we go. And you can see that every Monday, the key is every week is the same. So here, Monday it's always 4 hours, Wednesday it's always 2, etc. So simply to find the next one, it's k plus 7 equals ak. It's simply the every seventh value, every seventh term is going to be the previously same one. So it's not very difficult. It's not commonly used here. But I'll tell you what is interesting is the periodic sequences that oscillate between the minus and the plus. So here we have minus 1 plus 1, minus 1 plus 1, and it's fascinating. There's a tool here that we use, and it's a really neat tool. Get to know this one. It is simply bracket minus 1, close bracket, k. Now that starts with a minus. If we wanted to start with a positive, negative, positive, negative, positive, negative, we'd simply say k plus 1. So this one, minus 1 to the k, starts off with negative. Now let's take a previous example we had, that geometric series, and this time instead of 0.5, let's have minus 0.5, 1, minus 2, 3, minus 4, 8. Now we know previously that was a formula that came out, but now we want it oscillating between minus. We simply put in front of that minus 1 to the power of k, and that will switch the signs then. Pretty awesome. Now, the other thing we need to know, subsequences are increasing. They go from here to infinity. That's where the common difference is greater than 1 and the ratio is greater than 1. They work for both arithmetic and geometric, but also we have sequences that are decreasing. Arithmetic one where d is less than 1, and a geometric fraction, like a half or a third, then these will be decreasing. And sometimes we also have not just decreasing ones, but we also have diverging and converging. Diverging is just simply going lower and lower and lower and lower, never finding a point, whereas converging gets to a point, either from top to bottom or bottom up, decreasing to a point or increasing to a point. Here, it's decreasing, getting closer and closer to 0. So this is a converging geometric series. What about an increasing sequence? In this case, it's an arithmetic one. You can see the numerators at the top, you can see the denominators, how they work as well. So the top number is going to simply be k, and the bottom number is, it's like an arithmetic series, difference of 2, starts off with 1, so it's going to be k over 2k plus 1. And the question here is, where does it go towards? Is it converging anywhere? And you can do a really neat one. Say k is 1,000, that's 1,000 over 2,000. You can see where it's heading towards, 1,000,000 over 2,000,000. If you get the plus 1, it becomes insignificant. And the k's cancel out, so in the end you get 1 over 2. This converges to a half. So that's our sequences and series. Now if you go to exercise 3.1, have a look through that, and then when we meet up we can discuss some of those particular questions. I hope you found this really useful, and we'll talk to you later on. Keep safe.